Let's solve problem 11 where we have to find out the number of ordered pairs of integers mn that satisfy this relation. So for this problem, first I will rearrange the given equation. So the equation is here, and I will apply or take the square on both sides of this equation. So then I will be left with uh, n square minus 49 equal to m square. So now if I rearrange it, I would get then m square minus m square equal to minus 49, or I can write it like this. Okay, and now if we see that this is difference of squares, right, we can set it up like that. So I can write it n minus m and n plus m equal to 49. So from here now we can see like what ordered pairs will satisfy this equation, and those basically are the ordered pairs that are possible for m and n. However, from here we can make one observation that n plus m is greater than or equal to n minus m. So we need to keep this in mind. So based on this, we can see like what pairs are possible. So definitely we can have the first one could be then minus 49 minus 1. So it would satisfy this equation. So the second pair that is possible is minus 7 minus 7. That is also possible. The next possibility is 149, and then we can have 7 and 7. So the total pairs that are possible are then 4. So we do not need to explicitly find the values of m and n in this problem. Uh, but if you wish, you could do so based on the time that we have. It is better just to solve the problem to identify the ordered pairs that can satisfy this expression. That's all that you have to do. So the 4 is the answer for this problem. Let's look at problem 12, where we are given that Zelda played the Adventures of Math game on August 1st and scored 1700 points. She continued to play daily over the next 5 days. The bar chart below shows the daily change in her score compared to the day before. So what was Zelda's average score in points over the 6 days? So we have to find the average score that she has scored. So we are given this chart that shows the change in score, uh, like with respect to the previous day. So like if you see for day 1, she scored, let's say, 1700. Then day 2 is 1780, right? Because the score was higher. And then it was negative 90. So the day 3 score is 1690. Then day 4 score, if we calculate, that would be 1680. And then day 5 score is now we are adding 60, so it is becoming then 1740. And then we have day 6, so that score is dropping 40 again, so it's going back to 1700, right? And now we have to take the average, so we basically simply sum these days up and see what is the average. So that is 1700 plus 1780, 1690, 1680, 1740, and then plus 1700, right? So this whole thing, if we divide it by 6, so then we will get our answer, and if you solve it, then the answer that you get is 1715. So E is the answer for this problem. Let's look at problem 13, where we are given that two transformations are set to commute if applying the first followed by the second gives the same result as applying the second followed by the first. And we have to consider these four transformations. The first one is the translation, then a rotation, reflection, and a dilation. And we have to tell of the six pairs of distinct transformations from this list how many commute. So for this problem, let's say that our coordinate plane is xy, and now let's write the mapping for each of these transformation. So for the first one, xy, we get x plus 2y. The second one, then we can say is xy to minus yx. The third one is then xy to x minus y. The last one is xy to 2x, 2y. Also, let's name each of these transformations. The first one I would name as T1, T2, T3, and T4. So now we need to see which transformation they commute, right? So for that, what we have to do is simply, let's say first we check for T1 to T2, and then we will also check from T2 to T1. So basically what we're checking that if we apply first T1, then apply T2, or if I apply T2 first and then apply T1, is the answer same or not? So if I apply T1 first, so that would give me the x plus 2 y, right? And now if I apply T2 on this, then I would get minus y x plus 2. Okay, so now let's see if I apply T2 first and apply T1, what do I get? If I apply the T2 first, so I'm still starting with xy, and since I'm applying T2 first, then I would get minus yx, and then I get here minus y plus 2 and x, right? So if I see now both of these mappings or the results, they are not same, right? So therefore I would write it that do not commute. So this was the first pair, right? So similarly I have now five more pairs, so total pairs I have is 6. So now let's check one more pair, and then the rest you guys can solve it in the same way. So let's see the next pair that we are going to check is T1 to T3, and then we will check T2 to T3 to T1. So if I'm starting again with T1, now I have again xy. So I would get then x plus 2y, right? And then I'm applying T3. So then I get x plus 2 minus y, right? to minus y. And now if I apply t3 first, then I get x minus y. And now if I apply t1, I get the translation along x-axis, and I get minus y. So in this case, if we see now, the result is same, right? So we can say that commute. So in the same way, we will check for the next, like the pairs. So I will just write now the pair, and then I will let you guys do it yourself. So you will check T1 first, T4 second, and then T4 first and T1 second. And then we will check T2 to T3, and then we'll check T3 to T2. And then you'll also check T2 to T4 and T4 to T2. And how many pairs we have? We have 5 pairs, so then the remaining pair is now we will check T3 to T4 and also T4 to T3. So these are all the pairs that uh, you have to check. So if you check all the pairs, then you will find out that the uh, the pair that commutes, they are actually three. So the answer will be C. But I'm leaving it to you to solve. If you have any question, then write it in the comment section, and then I can explain there. Okay, so now let's look at problem 14, where we are given an equilateral triangle of a height 24, and it lies on line L. And then we are given a circle of radius 12 that is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and line L can be written in this form. So these are the positive integers, and b is not divisible by the square of any prime. So what is a plus b plus c? So in this problem, I have already drawn this diagram, as can be seen. Basically, what we have to do, we have to find the values of a, b, and c. And as it has been given already that the area of the region exterior to the triangle and circle bounded by this is represented with this expression. So basically, it means that this expression, it represents the area that is bounded by this region, bounded by these lines. Okay, so let's first label this triangle and also the circle, then it would be easier to work with. So let's say call it a, b, c. This is then, let's call it d, e. This is the origin. I'm just gonna call it o, and this is 12. And the height that I get from here to here, that is given as 24. So to find the area of the sector, what I can do, I can simply create a trapezoid. Okay, so the trapezoid I'm going to represent with the black lines. So now if from this figure we see that the area that we are interested in, that is simply equal to the area of the trapezoid minus the area of the sector, right? I'm talking about this sector, the this sector. Okay. Since the triangle that I'm given, it is an equilateral triangle, so all angles are 60 degrees. If this angle is 60 degree, so then the angle that is inside, that would be 120 degrees, right? And If this angle is 120 degree, let me write it clearly. So this is 120 degree angle. So then, as we know that this angle for the trapezoid and this angle, they are both 90 degrees. So this angle then is 60 degree. Okay. So from here we can see that to find the area of the trapezoid, we basically need to know the two sides. So two of that we know already, right? So let's say this is 12, we know this is 12, right? But we don't know the other two sides. However, what we can do, we can divide this trapezoid into two triangles, right? So now if I divide this trapezoid, okay, then I can get a triangle that is a 90, 30, and 60 triangle, okay? Then let's call this triangle X, Y, Z. So we know this is 12, and as we know for 30, 60, and 90 degree, we can easily get the other two dimensions if we know the one. So this dimension, it would be then 4 square root 3, and this is 8 square root 3, right? And that is simply twice the area of this triangle. That means I have 2 times 1 over 2 times 12 times 4 square root of 3, right? And the sector is simply 1 over 6 pi r square, right? And the reason is the sector that we have, that is making a 60 degree angle. So 60 divided by 30, 360, I get 1 over 6. And now if I solve, I get, then this cancels out, I get 48 over 3 minus 1 over 6 pi, and 12 times 12. And if you simplify, I get 2, and then I get 48 with this minus 24 pi. So from here now I can simply read a plus b plus c. So a plus b plus c, that is equal to now 48 plus 3 plus 24, and then the answer is 75 that I get. So this is how we can simply solve this problem. Okay, so now let's look at problem 15, where we have that let m be the greatest integer such that both m plus this number and m plus this are perfect squares. What is the unit digit of m? So let's first express both squares as p square and q square. So p square is equal to m plus 1213, and q square is equal to m plus 3773. And if I subtract equation 1 from equation 2, I can write as q square minus p square equal to 2560. M's will cancel out, right? And also now the left hand side, it can be represented as q minus p, q plus p equal to 2560, right? If we make one observation that we want m the greatest integer, right? So for that, we need to ensure that q and p are also maximized or the largest possible. And from there, we can also make one observation that we want then q plus p to be the maximum and q minus p to be the largest. So if I write the factorization for 2560, that give me the maximum value for q plus p, then one option is definitely this, right? So I can have q minus p equal to 1 and q plus p equal to 2560. However, if I calculate the values for q and p based on this, I would see that they are not integers. So I have this, and then if I plug this number and I solve, I get 2q equal to 2561, right? So that means that q is not integer anymore since it is divided by this, right? So then I will exclude this option and I will check the next option. In the next option, I can have 2 dot 12 right? So that is also, as we know, equal to 2560. And from here now, I can calculate the values for P and Q. And if I solve, then I would get, so if you solve these equations, then Q is equal to 641 and P is equal to then 639, right? Okay. And both of these are now integers. And now what we have to tell that what is the units digit of m, right? So what we can do, we can now write the equation in this way that m is equal to p square minus 1213, right? So now if I plug p square, that is given 639 square minus 1213. So now I don't need to solve this full square. All I know that the unit digit for 9, it's going to be 1, right? And there will be something before this. And minus 1213 I have. So then the unit digit that I will get, that will be 8, right? So I can also check now for the other case as well, where I have q square minus 1213, and here I have now 641 square, right? Minus 1213. So again, if I see the unit digit that I would get from here is 1 minus 3, so that would be again 8. So the answer for this problem is then E. Okay, now let's look at problem 16, where we are given that all of the rectangles in the figure below, which is drawn to scale, are similar to the enclosing rectangle. Each number represents the area of the rectangle. What is length AB? So it is important to understand that the larger rectangle, it is similar to the smaller rectangles. So that will allow us to write the ratios of the corresponding side lengths equal to the square root of the areas. So first we will calculate or get the total area for this larger rectangle by summing up these areas. So if we solve, then we get area equal to 200 unit squares. And now let's label this rectangle, and we're taking height as x, and height, it represents the smaller dimension, and we are representing y as the width, and width is representing the larger dimension of the larger rectangle. And now we will try to express the uh, the length of the smaller rectangle in terms of x and y. So I will start with the left hand side, and let's say that this side it is p and this side it is q. So now I can write it that p over x is equal to square root of 32 over 200, and that is equal to then 2 over 5, or p is equal to then 2 over 5 x. And similarly, I can also write expression for the next rectangle, and I can write it now q over y equal to 36 over 200. So I'm taking y here because we are uh, taking the larger length now. Okay, so q is the larger length and y is also representing the larger length. So that's why we are writing q over y equal to 36 over 200. And if we solve this, then we get 3 square root of 2 over 10. Or we can say that q is equal to 3 square root 2 over 10 y. So now what I would do, I can write the total height of the larger rectangle as x equal to p plus q, or that is equal to 2 over 5x plus 3 over 10 square root. Sorry, in this y. Okay. So if we solve this and we find the value of x, then we will get y over under root or square root of 2. Okay, I'm just skipping this step of solving this because it's just simply algebra and I'm pretty sure you guys can do yourself. So now what we have to do, we have to now find y, right? Or the value of y. So we know that the area is xy, right? And also we know x is y over square root 2 y, and area is 200. Okay, so now I can write it y square equal to 200 square root 2, or I can also write it like this, or we can write it as, so now if I take square root on both sides, I would get y equal to multiply by 100, and so sorry, it would be now 10. So now let's look at problem 17, where we are given that two teams are in a best 2 out of 3 playoff. The teams will play at most 3 games, and the winner of the playoff is the first team to win 2 games. The first game is played on Team A's home field, and the remaining games are played on Team B's home field. Team A has 2 by 3 chance of winning at home, and its probability of winning when playing away from home is P. Outcomes of the game are independent. The probability that Team A wins the playoff is 1 by 2. So we are given the total probability as well, and we have to find what is n plus n from this expression. Okay, so we see the probability of Team A when plays at home is 2 over 3. So in this case, the probability of the Team B when they're playing at A would be 1 minus 2 over 3. Okay, or it would be 1 over 3. And when team A is playing away, then the probability that we are given is P, and the probability for team B in that case, it would be 1 minus P, right? So now if we see, like, there are 3 possibilities that we have, right? Based on the description that we are given. So one of the probability is that team A wins first 2 games, right? So in this case, if we see, the probability then we will have, that would be 2 by 3 P, right? The second case that we have is team A wins the first game, then team B wins, and then team A wins the third game. So in this case, the probability that we will get, that is 2 by 3. For B, we will have 1 minus P and P, right? Now let's say we have, what's the third possibility? The third possibility is team B wins the first game, and then team A wins the next 2 games. And now the probabilities that we have is 1 over 3 14b, and for a's we will have the probabilities that are p dot p, right? Okay. So now we are also given the total probability, right? Team A wins playoff is 1 over 2, right? So then we can write that 2 over 3p plus 2 over 3 into p minus p square plus 1 over 3p square is equal to 1 over 2. So now we can simplify this equation, and if I multiply both sides by I would multiply by 6. Okay, so then I would get 3 here, and I get on this side 4p. Here I would get then again 4p minus 4p square, right? And plus I would get then 2p square. And now if I simplify, I would get minus 2p square plus 8p minus 3 equal to 0. Or I can also write it like this, right? And now I can apply the quadratic formula to find b. So that would be then equal to minus b plus minus b square minus 4ac over 2a, and then we get 8 plus minus 64 and minus over 4. I would get 40 over 4, that is equal to now 8 plus minus 2 10 over 4. Or I can further simplify and I would get them plus minus 10 over 2, right? And from here I can see or I can relate it with a given expression. So for the given expressions we were given the negative sign here, right? So if we discard the positive one, just keep the negative one, and then we can keep the values. So the values that we get for m plus n, so they are then 4 plus 10, that is 14. So the answer is then. So now let's look at problem 18, where we are given that there are exactly k positive integers b with this range such that the base b integer is divisible by 16. What is the sum of the digits of k? So we have to find out the positive integers b, which are in number equal to k, and then we have to sum up the digits of k. So if we see the number that we are given, it is given in base b. So we can write this number like this. So we have 2024b, that is equal to 2 multiplied by b to the power 3 plus 0 multiplied by b to the power 2 plus 2 multiplied by b to the 1 and plus 4 multiplied by b to the power 0. And if you see, we are already told that this number, it is divisible by 16, or I can write it that equal to 16x. So since this number, it is divisible by 16, and if you see that this number, it has 2 in common, right? So then I can also express this number as plus b1 plus 2, and that is equal to now 18x. So basically the number that we have, it should be divisible by 8. So now what we need to do, we need to find out for which numbers this number or this expression it is divisible by 8. So what we can do, we can start with 0 and go all the way up to 7 with 0 first. So, so if b is 0, then if we solve, we get, so then the remainder is 2. So that is not divisible by 8. Okay, so we will not count it. Next, let's check with 1. So now I get 4. That is still not divisible by 8. Twelve. So that is still not divisible by 8. Now I get 32. And 32 is divisible by 8. Now I will check 4. 70. So that is also not divisible by 8. I will check 5. So that is now equal to 32. So this is not divisible by 8. Now let's check 6. So if I solve for 6, then I get 216 plus 6 and 224. That is divisible by 8. So now let's check 7. So then I would get 352. So that is also divisible by 8. Okay, so now if we see based on our work that out of these 8 numbers, 2024 is divisible by 3, right? So what we can do now, we can find out all the numbers by simply dividing 3 by 8 and multiply by 2024. And that would give us then 253, and if we multiply, then we get 759. However, we should keep in mind one thing, that the range that we are given is b is greater than or equal to 5 and less than 2024. So then we have to subtract one number. That was this case 3. Since this is, it doesn't come in this range. So if I subtract, then I get 758. And now I will add these 3 digits to get all the k integers. So that is equal to then 20. So that is the answer for this problem. Let's look at problem 19, where we are given that the first 3 terms of a geometric sequence are the integers a, 720 and b, where 720 is greater than a and less than b. What is the sum of the digits of the least possible value of b? So we are already told that this is a geometric sequence. So based on that, we can write the ratio of 720 to a equal to b over 720 because of the common ratios. The common ratios are same in the geometric sequences. So now if I rewrite this expression, I can write it like this. B is equal to 720 multiplied by 720 over a. And now I have to answer that what is the least possible value of b. So if we look at this sequence, b is appearing after 720, so it should be greater than 720, right? So in order to get the largest possible value for b, a should be small, right? But it should be smaller than 720, and uh, so the b can be the least, right? So a should be less than 720, but the largest possible value for some, like less than 720. So now what we can do, we can get the factors for 720, and if I quickly do that, I would then get so these are the factors that I get for 720. So then I would write it as 2 to the power 4 multiplied by 3 to the power 2, 5 to 1. And now I would write the same for this as well, over a. So if I put these powers together, I can write it like, so once I have written it in this form, now all I have to do is to do some experimentation. With the experimentation, I have to find what is the largest possible value for this combination but less than 720. So for that, the condition that needs to be met is that this number or this value, it should be a multiple of a. So if I do some experimentation, then I would get 3 to the 3 multiplied by 5 to 2. That would give me the largest possible value. And if I solve it, then I get 675, and by adding the digits, I get then 18. So the answer is in D for this problem. So now let's look at problem 20, where we are given that let S be a subset of these numbers such that the following two conditions hold. If x and y are distinct elements of S, then the magnitude of x minus y is greater than true. If x and y are distinct odd elements of S, then x minus y, magnitude of x minus y is greater than 6. What is the maximum possible number of elements in S or in this subset? So let's first understand these two conditions. As per first condition, if we have two distinct numbers, let's say if I have 1 and 2, then the difference is 1, right? So that is not greater than 2 and it will not satisfy this condition. So in order to satisfy the first condition, let's say if I take 1, 4, it is 3. So it would satisfy this condition, right? So now similarly, let's check for x minus y, where we have distinct odd elements. So let's say that if I take now 1 as odd element and I take 5, it will not satisfy this condition, right? Because the difference is 3. So I will need a greater number or a greater odd number to have a difference of greater than 6. So to solve this problem, what we can do first, we need to actually find a pattern. Otherwise, it is not possible to check each number from this total set. So what we can do, we can start checking from first 10 and see if there is any pattern, or from first 20. And then based on that, we can find out like what are the total numbers that are possible. So I will write down here numbers up to 20. 1, 2, 3, 4, 7, 9, 10, 11, 12, 13, 14, and 20. So now, as we know, based on the first condition, 2 and 3 are not possible, right? So similarly, if I see, I have now 4, and the next digit then I can have, that is should be 8, right? So this is also cancelled out. And once I have 8, then the next digit that I can have, that should be then 11, right? And now if I check next, I would then get 14. And similarly, if I check the next digits based on the conditions, 18 minus 14, I would get then 4. And if I have 17, yeah, that would not. So then I would get, sorry, I would then get 18 as the next digit, and also 19 and 20 will not be possible. So now if I see from the first 10 digits, there are 3 digits which satisfy these two conditions, right? And now if I check the next 10, then again there are 3 digits which are satisfying this condition. So the total number that I am given is 2024. If I divide it with 10, because we are making this observation for every 10 numbers, then I can write it 202 remainder 4. And then from each of these 200, each of 10 numbers, there are 3 numbers which satisfy the condition. So it would be then 202 multiplied by 3 plus, since there is a remainder 4, and from the first 4 numbers, 2 numbers are satisfying the condition. So I can add, and then if I solve, I would then get 608. So that is the answer for this problem, C. I hope it makes sense to you.